index for each line. So it'll start 0, 1, 2, 3. You can yield, you can say yield key arrow value if you want to do a custom key. Yes?
If you in your for each loop you break out of it, does the rest of the function continue, like the file's closed, or is the file remain open?
If you break, it will continue with the rest of the function, yes. So you can use all the loop keywords, all the iteration keywords that you're used to, like break and continue, and this will continue to function as you expect it to. If you break out, it'll close. If you continue, it'll skip to the next iteration. PHP deconstructs this and creates iterator code in the background, for lack of a better description of that. So the keywords that you're used to will work there. It's just a lot shorter than implementing those 5 iterator interface methods. Any other questions on this function? Shall I go on? Let's look at something else. A very silly example now, because that previous one was very serious. Sorting arrays. Who has heard of the bubble sort array? Bubble sort algorithm. Okay. Bubble sorting is a silly algorithm. Sorting in general is quite a fascinating topic in PHP. Bubble sort, interesting, but silly. The process of bubble sorting can be explained in this implementation, but I won't go through the code to explain what I'll do. I'll use an example. Can I get some volunteers, please? 3 or 4 of you. Come right up. You gentlemen. One more person. Cool. Thank you.
Sorry.
Hi. Okay. These 4 gentlemen are part of an array that I want to sort. Can you stand sort of in the middle?
Yes.
And sorry about being blinded by the projector. Pick a number from 1 to 4.
3.
Hold it up with your fingers, please. Pick a number from 1 to 4. 2, 1, 4. Cool. Okay. And I am the bubble sort algorithm. Hello. What I want to do is I want to get these 4 elements of the array sorted in numerically ascending order. So to do that, I will look just at 2 items in the array at a time. I'll start off and I'll say, what is your value? 3. What is your value? 2. 3 is bigger than 2, so could you gentlemen please swap position? Okay. Depending on the implementation, you could have just changed your number values, but
no, it's way better this way.
Okay. These 2 items in the array. What is your value? 3. Your value is 1. You're bigger. Please swap.
I like the moving better.
Yeah, it makes sense. What is your value? 3. What is your value? 4. You're in the correct order, because your value is not greater than your value. Okay. Then I keep on going through this. So here, what is your value? 2. Your value is 1. Please swap. 2 and 3, you're in the correct order. 3 and 4, you're in the correct order. Algorithmically, most naive implementations will go through this list as many times as there are items in the array. But there's a shortcut. If your orders were 4, 1, 2, 3, if that were the order of items, the very first time I go through the entire list, number 4 is going to be all the way at the end. So each time I go through the entire list, I have to check 1 less item. Essentially, that's bubble sort. Thank you, gentlemen. Now this is a naive implementation of bubble sort. It does what I just described with the help of my talented array variables. And if I wanted to convert this to a generator, there's very few things I actually have to change here. All I can do is yield the items after each comparison and potential swap. Which, if you think about it, is actually interesting, because using this instead of the original iterative approach, I can now see what the list looks like after each comparison and each swap. I can watch it being sorted in real time if I want to, or I can just get the last item and write that out if I'm only interested in the final result. Now this is silly, for sure. You wouldn't actually try and do sort algorithms using generators, because most of the time you're not interested in the steps in between. You just want to have the final result. But you're still doing that calculation, so you can yield if you're really interested in the interstitial steps. And so far, we're not seeing anything new about generators here. We're halting execution at this point, and in the next iteration, we're going back to the top of the loop. And we keep on doing this until we're through I is equal to or greater than times, and then we end up stopping. But there are other aspects to generators that we can look at with this example. What if I wanted to halt the sort algorithm randomly? What if, given a 1 in 6 chance, I wanted the sorting just to stop, like a kind of bubble sort roulette? Well, I can use the send function on an instance of a generator to send data into it. And this part gets really tricky. Because inside the generator, I now have this kind of situation. Remember, yield sends the value out of the generator from what's on the right-hand side of it. But if you surround that yield value with brackets and you assign that to a variable, it will send data out through yield, and it will receive data in through the send method at the same time. You need to look at that for a while and look at examples of using this oftentimes to grasp what that's going on. I mean, for me, it took ages and ages to get on par with what's going on here. But this will return, sometimes it will return 0. And if it does, we want this to stop. So you can compare that to false, I guess, or you can compare it to 0, which would be more safe. And when you break inside the generator, it's not going to do any more iterations of sorting. What about if we sense something wrong with the result that the generator has given us, or something in the state of our application has changed and we want the generator to adjust itself for that state? We can do this. We can throw exceptions into the generator and have the generator manage what that means. It can still contain its own logic, but we can, if it has the capacity to manage errors in the rest of the application, we can send those into the generator. In this case, when we had the 4 gentlemen up here, we got them sorted after just 2 attempts. But the algorithm says, go through it the amount of times there are items in the array, which is 4 iterations. I didn't do that because I would have just said, don't swap, 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 don't swap. But generally, naive implementations go through the list of items as many times as there are items in the array, and that's very inefficient. What if we said, go through this list of 6 items, and if after 6 comparisons you've seen the same data set, it's obviously sorted. We can do that. We can check for repetitions of the same data source. If the repetitions are greater than or equal to the number of items in the array, then it's gone through 6 comparisons and not done anything meaningful. Then it can terminate. So we throw an exception in, and inside the generator, we just wrap the yield in a try-catch. It's a similar sort of feeling to what we do with send, where we get data in. Except now, instead of assigning that to a variable, we're just catching an exception that's been thrown into the generator. Using these kinds of concepts, the ability to halt a function's execution, the ability to send data in, to throw exceptions in, we have what we can use as interruptible functions. And other languages call interruptible functions coroutines. This is something that until generators, we could simulate using iterators, as we've seen, because they're very similar to generators. But generators give us a very nice syntax for this. And maybe we can do something interesting with that. So I'm going to write some code. And I have positioned myself terribly to do so. Sorry, sir, do you mind if I put my laptop here? Okay. The code I want to write, I think, is very simple. Only because I've looked at it so much in rehearsal. What I want to show is that we can use generators to do a very simple kind of cooperative multitasking. And what that means, what cooperative multitasking means, is that in a given system, tasks in the system do a little bit of work each and then surrender control back to the processor, so that tasks further on can do a little bit of work. Each task is cooperative in that it cedes control back. So, let's write some code for doing that. I think we can have a scheduler, a kind of thing that manages different tasks and does a little bit of work in each, and a task class, just something to give us a little bit more utility around a generator. So what does this code look like? Well, we mentioned two classes. The first I want to make is the task class. This will wrap a generator and give us some methods on top of it. Some methods where we can treat a generator as if it was a multitasking thing. Now, because we're going to decorate a generator, we need a place to store that, so we'll just make a protected variable for that. And a good place to bring this generator into the class is through the constructor. But I'm not going to type hint it. If you do work with generators, you can type in the generator interface or the generator class, and then if you pass in something else, you can get a nice validation error for that. I'm not going to type into this because we'll see why later. But now we want to store this to our temporary variable. And in order to make these work nicely with each other, we should probably have a way to run a single unit of processing in this generator, and another way to tell when all processing is complete. Fortunately, because generators mirror iterators so closely, we can use methods there to help us to do this without a lot of boilerplate at all. Those two methods again are to run this task, a unit of work of this task, and to see if there is still more work to be done. So I'll call them run and valid. Ooh, that's interesting. This, not so much. Okay. This looks really weird. Hands up if this doesn't look weird. Yeah, this looks really weird, right? It feels like kind of an abuse of iteration in general. But here's an interesting thought. Can we think of functions like a data lookup table? Who would disagree with that kind of statement? That a function can be used like, or thought of like a data table. Given the same inputs, whether they are functional parameters or whether they are some other state in your system, given the same inputs, your system is likely to generate the same outputs. You can map the input of a function in your system to the output it will give. It's consistent. Computers are just going to do that for you. And I guess I need to qualify that statement to say perhaps something weird can happen. But by and large, a function is just a lookup table for inputs mapping to outputs. We're so used to thinking of iterators and of arrays just as lists of items that we've forgotten that maybe items in an iterator can be thought of as units of work that generate that value. And generators specifically reinforce this idea in their name and in how you make them. To get an item out of a generator, this iterable thing, you make a special function. You calculate that value before you yield out of your generator, or your generator is not yielding anything significant. You do work to get value for each cycle of a generator, and you do that same work if you're making this as an iterator. It's just that we're very conditioned to think that iterators, perhaps generators, arrays, are all lists of fixed data, and not to consider the work it takes to get those data items in the first place. So this looks abusive. The more you look at it, the more you'll come to like it, I find. A task.